Guys, this is take 3 of this video. I know it doesn't seem like I stop and start these suckers, but I have tried this one 2 times already, and this is going to be number 3. I almost said 3 times already, which would make this the 4th, and which that would have been weird because I would have had to restart it. But anyway, what we're doing here today is limiting reactant, and essentially, kind of like if you're making sandwiches for a party and you have a certain amount of bread and you have a certain amount of bologna and some cheese, and every sandwich needs 2 pieces of bread, 3 pieces of bologna because we're doing it right. It's a party. A piece of cheese and maybe a pickle. You're going to run out of something eventually. There's not infinite pickles in the universe. And so that pickle, if you run out of it first, that's a limiting reactant. If you run out of bread first, that's a limiting reactant. And so when you look at this equation, when we start a chemical reaction with 80 grams of the iodine 5 oxide and 28 grams of the carbon monoxide, eventually one of them is going to run out, okay? And we just got to figure out which one. And this will show you how to do that. Now, the first thing I want to look at is, I can tell you right now that this is it's an oxidation reduction reaction because the carbon right here paired with an oxide is going to be a +2. It's going to go to a +4 here in the carbon dioxide. And we'll talk about oxidation states. Don't worry if you haven't seen that video yet. And then here the iodine is like a +5 because the oxide is 5 times 2 is -10, and then you divide it across the iodine. 10 divided by 2 is 5. So iodine goes from a +5 to a 0, so iodine is reduced. Because if we remember from oxidation and reduction, any element is a 0. So since iodine's elemental here, it's a 0. But what we have to do is balance the equation first, because right now it just looks kind of a mess here. So what I have here is I got I2O5, and then I'm going to try a 5 here and a 5 here. And so 5 plus 5 is 10. 5 times 2 is 10. Okay. All right. That works for me. Okay, so here I balanced the equation, and what I needed was 2 5s. And essentially, how you could look at that is that 5 is not going to balance over here with a 2. Okay, so 5 and 2 is 10. So I wanted 10 here, and then the easiest way to get 10 here would be to put the 5 here. 5 and 5 is 10. So we're ready to go on that. So rule 1 when you're doing any stoichiometry problem is make sure your equation's balanced. So now that we've got a good balanced equation, we're ready to go. Now, the next thing that I need to figure out is how much of the product, and we can pick either product. I don't care. I'm going to do carbon dioxide. You could use iodine. If you're just trying to figure out the limiting reactant, it doesn't matter which product you pick as long as you pick the same product for both reactants. So how much carbon dioxide can I get from 80 grams of this iodine 5 oxide? And then how much carbon dioxide can I get from the 28 grams of the carbon monoxide? So I'm going to make some ratios here. So I'm going to start out with 80 grams of I2O5 gas. And then I'm going to switch it to moles. So 1 mole I2O5 is, I wrote this down earlier. Don't think I'm like trying to short you out here. I'll just did it already and wrote it down on this sheet of paper for time's sake here. And then, okay, so that just switches my iodine 5-oxide to moles, and that's important. So you want to switch it to moles. And then I want to go from moles of this to moles of carbon dioxide. So in my chemical equation, that is a 1 to 5 ratio, okay? I get 5 carbon monoxides for every one of these I throw in. So what I'm going to do is I'm just going to set that ratio up, and I'm going to put the 1 mole of I2O5 on the bottom, and then the 5 moles of CO2 on top. And you know, you can leave it in moles if you're just doing limiting reactant, or you can take it all the way to grams. I'm just going to take it to grams, and because I know that 44.01 grams of CO2 is in 1 mole of CO2. Okay, and so there's a ratio, and I know it looks impressive because most things I write up look impressive, but it's really easy. You just take your reactant, switch it to moles, and then the middle one here just relates the reactant to the product. So whatever coefficient we have on the product we want goes on top, and then the coefficient of the reactant we have that we're trying to get rid of goes on the bottom. And then boom, here you got 44 grams. We're looking good there. And now I'll just go ahead and calculator that out because I got my calculator right here. And so that's going to be 80 divided by 333.81 times 5 times 44.01. And so 80 grams, I can make like 53 grams of carbon dioxide. Okay, so from 80 grams of iodine 5-oxide, I can make 53 grams of carbon dioxide. Now, 28 grams of CO, not CO2, CO, carbon monoxide. Okay, and then I just got to do basically the same thing. 1 mole of carbon monoxide is 28 grams of carbon monoxide. And then my ratio is going to be different because if I need to put in 5 carbon monoxide to get 5 carbon dioxide. So that's going to be a 5/5 ratio, which is going to cancel out. So 5 moles of CO2 from 5 moles of carbon dioxide, carbon monoxide. And then again, the molar mass of carbon dioxide is 44.01 grams CO2 in 1 mole of CO2. And so 28 divided by 28 is 1 times 5 divided by 5 is 1 times 44.01 is 44.01 grams of CO2. So here is what we have figured out. If I have 80 grams of the iodine 5-oxide, I can make 53 grams of carbon dioxide. I have enough of this to make 53 grams of the product I want. Here, though, if I start out with 28 grams of carbon monoxide, I can only make 44 grams of carbon dioxide. So the 28 grams of carbon monoxide is the limiting reactant. There are only 2 possible choices for limiting reactant. It's either this or this. It can't be one of these, okay? What I get a lot of times is people say, oh, it's the carbon dioxide. No, it can't be a product. When we're talking about limiting reactant, it's either this or this, something on the, something on this side. Now, the other thing, Just because we started out with less of this and ended up being the limiting reactant, that doesn't mean you never have to do the math. You always have to do the math to figure that out. So anyway, now you can confidently say that 28 grams of carbon monoxide is the limiting reactant in this here chemical reaction.